So in this video, we're going to be covering a few examples of converting ER models or mapping ER models into their equivalent relational models. So before we can even do something like that, we would need to understand the similarities between a ER model and what its equivalent is in a relational model. So the attributes in an ER model is actually basically the same thing as the attributes in a relational model. And then an entity set is basically a relation in a relational model. Also, a relationship in an ER model is considered a relation as well in a relational model. And finally, an entity by itself, so not an entity set, is considered a tuple in a relational model. And now that we've identified everything in an ER model and its equivalent in a relational model, it's very easy to map it. So we know that the name of the relation is student. We know that the attributes are the same, so we have the student ID. Notice how that's been colored. We've preserved the idea of the primary key. And the other attributes are name and degree, which are also here. Yep, so that's been a mistake. That should be degree. So here's another ER model that we're going to be mapping into a relational model. So this is an example using weak entities. So the first part is very easy. It's just like the previous example. We have our relation, the employee. We have the attributes. And so that's the first relation, employee, the SSN, which is basically the primary key, the electronic name, the employee name, the salary. And so moving on to the weak entity called contact. Remember that we discussed that weak entities having a discriminator instead of a primary key. And the primary key instead is you have to combine the discriminator along with the primary key of the strongly associated entity. So basically in the relational model, it's very similar. You have the contact relation, you have the name and phone attributes, but you also include the SSN, which is the primary key of the strongly associated entity, and the name discriminator. So by coloring both of them, you're indicating that both of them combined is the primary key of the contact entity, which is known as a composite key, which basically shows that weak entities can't exist without the reference to their strongly associated entity. And so here's a third example of an ER model that we'll be mapping to a relational model. This one includes relationships along with its associated attribute. And so the first two relations are actually very similar to what we've done previously. So we have the customer entity. You would just map over to a customer relation along with these attributes, and this would be the primary key. Same thing with this one. I'll just show that now. And so here's how the first two relations look like. We have the customer relation name, customer number, which is the primary key, it's been colored in, name and address are the attributes. The second relation, account, as well as its attributes and primary key, account number, title, and balance. And so here we have to map this relationship in an ER diagram into a relation as well. And so here we have the owns relation. The owns relationship name, it just translates over. And here we can see the associated attribute, last access, that's also translated over. And because every relationship is connected to a customer entity and an account entity, we would need to include the primary key of both here. And so basically every account number and customer number combine to give us a composite key, which basically tells us which customer owns which account. And then that way we can get the data on when it was last accessed. And one thing I want you to understand about the owns relation, an account number could be repeated and so can a customer number. However, together they can't be repeated because together they're supposed to represent a unique element or tuple in the owns relation. And so in this example, it almost looks identical to the previous example. So you would think we'll just have a customer relation with the attributes, customer number, name, and address, with that being the primary key. And then a branch relation with address, assets, and branch number being the attributes. And then we'll also have a third relation, has home, along with the joint attribute and the customer number and branch number acting as a composite key like last time, right? However, I'll show you that it's actually different. So in fact, this is how the relational model looks like. So we have the customer relation, the branch relation. However, we don't have a third relation for has home. Instead, the associated attribute of has home is listed as part of the customer relation, and the branch number of the branch entity is listed as a foreign key in the customer relation. So you might be wondering what's going on. This has got to do with the cardinality of this relationship. Basically, a customer, from what we know, a thick line represents one, has at most one, and the arrow represents one as well. So a customer has at most exactly one branch associated with it. So from the previous example, so as you can see, the difference here is that here there was a thin line and no arrows on both sides. So this indicated a customer could have multiple accounts, and an account could be associated with multiple customers. So in this case, you needed the owns relation to be on its own. So this is the reason why in this case the owns relation needed to be a separate table and not be included as part of the other relations. And so here's another ER diagram example that will better demonstrate this. You might think, okay, there should be 1, 2, 3, 4, 5, 6 relation tables, right? But that's wrong, because the reason is here the customer can only be associated with one branch. You see that arrow? That indicates up to one only, right? Same thing with account. An account can be held at only one branch, again with that arrow limiting it. The only thing that isn't limited, the only relation that isn't limited, is basically between a customer and an account, where a customer can have multiple accounts. Notice how there's no arrow limiting it. And an account can be owned by multiple customers. So here, this is the only relation that would have its own table. And so here's how the relation model looks like for that ER diagram. We have the account relation, we have the customer relation, and we have the branch relation. And we only have one of the relationships which has its own table, right? And this has got to do with the fact that there's no arrow on either side. So this one needs to be represented. So the fact that an account can have many customers and a customer can have many accounts, here's how that would look like. It would combine to provide one composite key, which can show which customers own which accounts. Basically, let's say we have this customer. We want to know which accounts he has. We go into the held by relation table, and here we can find him in the customers. And then we can find its equivalent accounts. Or they could have multiple accounts, but once we find that, then we can go into the account relation and see the more details about all the accounts they potentially have. And notice how the reverse can happen as well. Say we have an account and we go into the held by relation, and that account could have multiple customers. So there could be multiple examples of that account number, and they could be lined up with different customers. And then we could just get more information on each customer that owns that particular account. And notice these two arrows, right? So that indicates an account can be associated with at most one branch. So the branch name would basically be listed as one of the account's attributes. As you can see here, the branch name is listed as a foreign key. And similarly, the customer relation, again, can be associated with only one branch. So the branch name would also be a part of its attributes and listed as a foreign key. So I'll just show you that. There we go, the home branch. And so whenever an account entity wants to know more about the branch that it's a part of, it just basically needs to follow its foreign key to the branch relation, and you can find the information on the address and assets. Similarly with the customer relation, if it wants to know more information about the branch that it's held at, the branch that it's a part of, all it needs to do is again follow its foreign key to the branch relation and get more information like the address and the assets. So I want you to also note that we can have, if we want to, a home relation by itself and a branch of relation by itself. But what we're doing is basically specifying that a customer can then have multiple branches in that table. So by limiting it and putting it only as part of the customer relation, the home branch, like as a foreign key, we're kind of forcing the customer to only have at most one home branch. Similarly with the account, we by specifying it like this as part of the account relation, we're forcing it for the account to be a part of at most one branch. Also note the fact that account has a thick line here. That means that here, for instance, the branch name must always exist. If this was a thin line, this could also be a null value. However, the thick line means that a account must always be a part of a branch. Similarly, a customer, the fact that there's a thick line, must always be associated with a branch. So this can't be a null value either, this foreign key. And similarly, an account must always be associated with exactly one customer, and a customer must similarly be also associated with exactly one account. Means in this relation table, they're held by relation table. An account can't exist on its own with a customer null value, or a customer exists with an account null value. So that can't happen either. And so here we have another ER model that again looks very similar. Um, so in this case, you might be wondering, well, okay, there's an arrow here and there's an arrow here. So each manager will be associated with exactly one branch, and each branch can be associated with up to exactly one manager. And so in this case, you're probably wondering, okay, so we're going to have the manager relation, we'll have the branch relation, but so what do we do with the managers relation? Are we going to have that on its own? So the managers is not going to be a relation of its own, but the either the branch number could be a part of the manager relation, or the employee number could be a part of the branch relation. So in this case, we've given the branch number of the branch relation to the manager relation. As you can see here, it's listed as a foreign key. This is actually a better practice, because as you can see from the thick line, this indicates that a manager must always be associated with exactly one branch. So there will never be an instance of a branch number here that's listed as null. But on the other hand, if we had given the employee number to the branch relation, from the thin line, there can be some branches without a employee, sorry, without a manager. We would have some null values, and it's better practice not to have those. And so in the event where this is a thin line, in that case, it really doesn't matter which side you give the opposite foreign key as part of the others attributes. And you would have to include any associated attributes of the relation as part of that one. And so in this model example, we have composite attributes. So we have the address attribute, which is basically made up of a combination of other attributes that are associated with it, like related to it. The number, the street name, the suburb, the postal code. And on here we have another composite attribute of the name, which is made up of the given name and the family name. Now, as you can see from the right side, there's two different ways you can map this to a relational model. One way is to concatenate all of these attributes into one singular attribute. So number, street, suburb, postal code could all be concatenated into the address attribute, which is listed here, similarly with the name one. Another way would be to just ignore this one and just consider all of these attributes instead. So you have the given name, the family name, but we've ignored the name attribute. Similarly, we've got the number, the street number, the suburb, the postal code, and we've ignored the address attribute. So those are the two different ways. And so here's another diagram. We have the person entity, which has a primary key of their SSN, and they have a name, birthday, and favorite colors attribute. Now, as you notice, the favorite colors attribute is a multi-valued attribute. And I'll just show you how that's represented. So basically, we'll have the person relation and include the name and birthday, but then we'll have the favorite color as its own relation, and we'll include the SSN of the person relation and the color as a composite key, which represents every distinct tuple of the favorite color relation. So this isn't colored in, that's actually a mistake. So for example, we'll have multiple SSNs that are repeated, but each color would be unique with that SSN. So if you actually notice, this is very similar to the premise of a weak entity, where the favorite color only exists out of an association with a strong entity. The color is basically a discriminator, which on its own isn't unique, but with the combination of the SSN makes one unique composite key. So you might notice another mistake here as well. A favorite color must be associated with exactly one person. So that should be a thick line, and it should be also an arrow here as well. On the other hand, this part's correct. A person can have 0 to many favorite colors. So thin line, no arrow, that part's correct. And so this is how it would look like in practice. So we would have for example, you would have the SSN, the name, the date of birth, and the favorite colors would come up as an array. But you have to understand, in relational modeling, they only use atomic values, so this can't come up as an array here in person. Instead, we have the favorite color relation, and it's separated like as a tuple for each one. So we have three of the same SSNs, but along with its color, it makes a unique example. And so next we have a ER model with subclasses. This can be represented in a relational model in three different ways, and I'll show you each one. And so here's the first example of the mapping to a relational model. It's known as the ER style. So basically each entity becomes a separate table, and each entity contains the attributes of that specific subclass. So for instance, the employee contains the salary and the position attributes. The manager only contains the bonus. The person contains the name and address. But all of them contain the parents, so the highest parents primary key. So SSN, SSN, SSN. And so here's the next example. It's known as the object-oriented version. So each entity again becomes a separate table. However, each entity contains all the attributes from the superclass. So for instance, the employee contains the name and address as well as its own attributes. The manager contains the name, address, salary, and position, as well as the bonus attribute. And finally, in the last version, it's known as the table with nulls mapping version. You basically just have one relation, the super parents relation, and then you just include all these subclasses attributes as part of the super parents attributes. So in a lot of cases though, there's going to be null values for a person who isn't an employee or isn't a manager. It's just going to be null and null. So it introduces a lot of redundancy. And so the last example I want to talk about is, imagine in this ER model's case, we had one entity, two entity, and a third entity that connects here. In this case, it would be considered a N to N to P relation. And the way you use that, it's very similar to this. You would have owns as its own relation. And you just include the primary key as a foreign key to the owns relation. And you would have that obviously as its own relation as well, and its attributes.